Welcome to the lecture series on time value of money, concepts and calculations. The topic of the present lecture is perpetuity. A perpetuity is an annuity that provides an infinite stream of equal cash flows received at regular intervals over time. Since this type of annuity is unending, its sum or future value cannot be estimated. However, the present value of a perpetuity can be calculated. Therefore, in a perpetuity, once the initial fund has been paid, the subsequent payments will flow from the fund indefinitely, which implies that these payments are nothing but the annual interest payments. One of the example of perpetuity is the British issued bond called consols. The present value of a perpetuity is the perpetuity's cash flow at the end of period 1 A divided by the interest rate I. So, PV is equal to A by I. Derivation of perpetuity. A perpetuity is a series of equal payments over an infinite time period into the future. Consider the case of a cash flow. Here at the end of first year there is a payment A, end of second year there is another payment A, end of third year there is another payment A, and this goes on up to infinite. Now, if we want to find out what is the PV, that is present value of this perpetuity, this derivation is made. Present value is given by an infinite series. So, PV is equal to A divided 1 plus I. So, when I transport this amount to present value, it will be A divided by 1 plus I, and when I transport this amount to the present value, this will be A divided by 1 plus I whole square. Similarly, it will be A plus I whole cube up to infinite. From this infinite series, a usable present value formula can be derived by first dividing each side by 1 plus I. So, when I divide PB by 1 plus I, this is PB 1 plus I, and this becomes A divided by 1 plus I whole square, this becomes A divided by 1 plus I whole cube, and so on so forth. In order to eliminate most of the terms in the series, subtract the second from the first. So, it becomes PB minus PB 1 plus I is equal to A divided by 1 plus I, and when we solve this equation we get PB is equal to A by I. Now, let us take few problems. Example 1. What will be the value of a single annual payment of a perpetuity cash flow beginning 1 year from today if the interest rate is 9% and the payment of 10 lakh is done today? So, PB is equal to A by I. So, PB in this case is 10 lakh, I is 9%. So, A is PB into I. So, it is 10 lakh into 0.09 is equal to 90,000. Hence, the annual perpetual payment A is 90,000. Now, question number 2. What would you be willing to pay for infinite stream of annual equal cash flows of rupees 1000 each received beginning 1 year from today if the interest rate is 10%. So, the formula is PV A by I, A is 1000, I is 10%. So, PV is equal to A by I, this is 1000 divided by 0.1 is equal to 10,000. Thus, one has to deposit 10,000 today to get a infinite stream of cash flows of 1000 per year. Let us take the example 3. While planning his after retirement life, Ravi estimated that if he receives rupees 20,000 on retirement date and also each month thereafter, he will be comfortable. He also wishes to pass on this monthly payment to his future generations after his demise as a gift. As per the present scenario, he can easily earn interest of 9% compounded annually. How much money he should set aside on the date of retirement, so that he starts getting his payment of amount rupees 20,000 on his retirement date and on each month after it for an infinite period. Now, if we see here, the I per month is equal to I per year divided by 12. So, this is 0.09 divided by 12 is 0.0075, and PV is equal to A divided by I is 20,000 divided by 0.0075, which comes out to be 26,66,666.7. If Ravi want to get rupees 20,000 on the date of retirement, that is on the same date he deposited the money, then he has to add rupees 20,000 with the computed amount of rupees 26,66,667.7, which comes out to be 26,86,666.7. Thus, if he deposits this amount on the day of retirement, then immediately he gets rupees 20,000 as first payment, and the rest of the fund, that is rupees 26,66,666.7, will provide him future payments of rupees 20,000 per month thereafter. The present value PB of the perpetuity is the perpetuity's cash flow at the end of period 1, which is A divided by the interest rate. Let us take an example. Mr. Anshu Agrawal wants to give a scholarship to IIT Roorkee. Under this scholarship, every year some student will receive rupees 1,000 and you are paying for it. Even after you, your kids and your grandkids are dead, you are still paying for it forever. The question is, how much money will it cost you in today's rupees? In other words, what is the present value of this perpetuity when interest rate in your bank is 3% per annum? A solution: every year the interest Mr. Anshu Agrawal earns is used to pay for the scholarship. The principal in the bank account does not really change year to year. So, PB of a perpetuity is equal to payment divided by interest rate. So, PB is equal to rupees 1,000 divided by 0.03, which comes out to be 33,333. So, if Mr. Anshu Agrawal deposits rupees 33,333 into the bank, each year the money will earn rupees 1,000 interest, and that interest becomes the scholarship. Another example: Hari is thinking of buying some stock in a company listed on the Bombay Stock Exchange BSE. Before Hari buys any stock, he should compute a price based on the dividends that he expects a stock to pay in the future. This company has paid a rupees 2.50 dividend every quarter for the past 12 years, and thus it can be expected that this trend to continue for infinity. What should be the expected price of this stock if Hari expects return of 15% quarterly compounded? The solution is, given that A is equal to rupees 2.50, rate of return is 15%, quarterly rate of return is 15% divided by 4, which is 0.0375. So, PV is equal to 2.50 divided by 0.0375, which comes out to be 66.67. With the exception that the company will continue to pay rupees 2.50 dividend every quarter indefinitely and a 15% required rate of return, he believes the stock price should be 66.67. Now, we will see the derivation of another type of perpetuity, which is called growing perpetuity. Sometimes the payment in a perpetuity are not constant, but rather increases at a certain growth rate g, as depicted in the following timeline. If you see this timeline, At the end of 1 year we are getting an amount A, but end of second year we are getting an amount A into 1 plus g, and third year we are getting an amount A into 1 plus g whole square, and so on so forth up to infinite period. This is a timeline for a growing perpetuity. Let us try to find out what is the PV, that is present value of this type of perpetuity. So, because this cash flows continues forever, the present value is given by an infinite series. PV is equal to A divided by 1 plus I. So, if this A is converted to present value, so the present value of this A will be A divided by 1 plus I. The present value of this A into 1 plus g will be A into 1 plus g divided by 1 plus I whole square, and so on so forth up to infinite. From this infinite series, a usable present value formula can be derived by first multiplying each side by 1 plus g divided by 1 plus I. So, if I multiply this PV with 1 plus g divided by 1 plus I, so this is PV 1 plus g divided by 1 plus I. So, this becomes A, this factor becomes A into 1 plus g divided by 1 plus I whole square, and so on so forth. In order to eliminate most of the terms in the series, subtract the second equation from the first. So, it is PB minus PB 1 plus g divided by 1 plus I is equal to A divided by 1 plus I. So, this gives PB is equal to A divided by I minus g, where I is greater than g. So, this is the formula for growing perpetuity to find out the present value. Now, let us take some numericals. If you invest in stock that will pay a dividend of rupees 20 next year and grows at 6% per year, and you require a 15% rate of return, how much is the stock worth to you today? So, here A is 20, G is 6%, I is 15%. So, PB equal to A divided by in brackets I minus G, it comes out to be rupees 222.22. Let us take another example. What would you pay for a share of stock given a required annual rate of return of 15% compounded quarterly and the following information? The next quarterly dividend will be rupees 2.25, and it is the company's policy to increase the dividend by 3% each quarter. Also calculate how much you will pay for constant perpetuity of rupees 2.25. The solution is, recognize that this is a constant growth perpetuity problem because the dividends continue forever and grow at a constant rate of 3%. You can use this equation to decide how much you would pay for the stock. So, PB is equal to A divided by I minus G, and what are given is A is 2.25, G is 3% each quarter, and I is equal to 15% annually return, and PB is what. So, I want to find out what is the value of PB. Now, quarterly rate of return will be I is equal to 15%. So, 0.15 divided by 4, this will be 0.0375. So, PB is equal to 2.25 divided by in bracket 0.0375 minus 0.03, which comes out to be rupees 300. Clearly, a stream of payments that gets larger every quarter is worth more than a stream of constant payments. One pays rupees 300 for this constant growth perpetuity, and how much would you pay for it if it did not grow is 20 divided by 0.0375, which comes out to be 60. So, we see that for a constant perpetuity we have to pay 60 rupees, and for a growing perpetuity we have to pay 300 rupees. Now, another example. Since graduating for college we have grown rich. As a gesture of goodwill, you have decided to endow your alma mater with a research grant in finance. The endowment calls for the grant to be a constant growth amount paid once a year in perpetuity. The first payment will be rupees 10,000 and is to be made in exactly 1 year, with subsequent payments growing at the rate of 6% annually. If you are able to secure a 8% annual rate of return on the endowment fund, how much should you put into the endowment fund today? So, we have a growing perpetuity. At the end of 1 year, the perpetuity is A, then at the end of second year, this is A into 1 plus G, and so on so forth up to infinite period. So, in our case A1 is 10,000, G is 6%, I is 8%, and what is the PV, that is present value, which I should invest to get this growing perpetuity. So, PV is equal to 10,000 divided by 0.08 minus 0.06, which comes out to be 5 lakh. So, to set up the endowment today, assuming a 8% rate of return will cost you rupees 5 lakh. Now, let us take another complex problem. A chemical manufacturer wants to issue some new equity to its stockholders. You have been hired to price its stocks based on its current dividend policy and its shareholders' required rate of return. The company has told you that over the last 3 years it paid stock dividends of rupees 1.10, rupees 1.13 and rupees 1.16 respectively. The company has also assured you that this growth rate in its dividend will continue indefinitely. If the company will pay its next dividend in exactly 1 year and believes that its stockholders require a 12.85% rate of return, what should be the price of its stock? Use an average of the growth rate of dividend payment over the last 3 years and the formula for the present value of a constant growth dividend, compute the stock price. Now, in the last 3 years, if you see here, in the last 3 years it has paid 1.10, 1.13, 1.16 and 1 year hence from this point it will pay A1, which we do not know. So, the solution is PB equal to A1 divided by I minus G. PB is the present value of the growth annuity, the stock price, and A1 is the payment received at the end of the first period. I is the periodic discount rate, which is 12.85 annually, and G is the periodic growth rate, annual growth for this problem. The problem does not provide the dividend at the end of the first period, that is A1, or the periodic growth rate G. It does, however, give the dividend for the last 3 years. Therefore, estimate the growth rate given the last 3 years dividends to find the value of G. Then use this to compute the payment at the end of the first period, that is 1 year's growth. There are several techniques that can be used to solve for the growth rate, of which one come up with 2.62%. By using simple average, compute the percentage change year to year and take the average. If G12 is the growth rate from year 1 to 2, G23 the growth rate from 2 to 3, then G12 is equal to 1.13 divided by 1.10 in brackets minus 1, which comes out to be 2.73%. Similarly, G23 comes out to be 2.655%. So, average is 2.73 plus 2.655 divided by 2 comes out to be 2.6925%. Now, if we take a geometric mean of this percent change, this is 0.23 into 2.655 and root of this 2 multiplications comes out to be 2.6922%, almost same as the arithmetic mean. Now, the compound growth rate from the previous section on the present value of a single cash flow, the internal rate of return can be computed as this: I is equal to A n divided by P v to the power 1 by n minus 1, and this, if I use the last one and the first one, that is 1.16 and 1.10. So, it is 1.16 divided by 1.10 to the power half minus 1, which comes out to be 2.691. Based on the estimated growth rate of 2.62%, compute the dividend at the end of the first year, that is A1 using A0 is equal to 1.16 as the current dividend. This produces A1 is equal to 1.16 into 1 plus 0.0262, that is 1 plus G, is equal to rupees 1.1904. The dividend to be paid in 1 year at t equal to 1 is rupees 1.16 in brackets 1 plus 0.026, which comes out to be rupees 1.1904. The dividend to be paid in the 2 years at t equal to 2 is 1.16 in brackets 1.1 plus 0.026 whole square, comes out to be 1.222 and so on up to infinite. So, PV is equal to 1.1904, which is the value at t equal to 1 divided by in brackets 0.1285, which is the rate of interest minus the growth, which is 0.0262, which comes out to be rupees 11,636. So, you can inform the company that with the implied growth rate of their dividends and their stockholders required rate of return, they should expect to sell the new equity at a price of rupees 11.636 per share. Thank you.